Hey guys, I'm a verified educator at Unacademy, and along with that, I'm also teaching live at Unacademy Plus. To access my live classes, you can take Unacademy Plus subscription. Now, Unacademy Plus offers some interesting features apart from live classes, which include detailed and complete explanation of a particular course. Then there you have problem discussion for self-evaluation. You can also watch recorded version of the class in case if you miss out any live session. You have regular doubt clearing sessions for doubt clearing and to clarify all your problems. You also get access to the WhatsApp group to clear and discuss problem among the other plus students. Now, if you have found these features interesting and want to join Unacademy Plus, I'll recommend you to use my referral code that is n_huda to get 10% discount on the subscription fee. Now that's all about Unacademy Plus. Let's continue with our video. Alright, so we will take this question which was asked for 2 marks. Okay, this was asked for 2 marks in your CSIR June 2019 exam, and this was from your pericyclic reactions. Okay, basically from the Diels-Alder reaction, and it was given that correct order of reactivity of following dienes towards your reaction with maleic anhydride. Okay, so let me just first tell you that what is maleic anhydride. So this particular molecule is your maleic anhydride. It's a dienophile, right? So it's a dienophile. You need a diene. Okay, so like there are three options given to you, like three molecules in each options given to you. One is like E 1 chlorobuta 1,3 diene, second is E penta 1,3 diene, and third is E 1 methoxybuta 1,3 diene. Now before going into that, you should know about what is E and what is Z. Okay, that means if you have this is a alkene, and if I have two groups, let's say this is a group A and this is group B, if they are trans to each other, if two bulky groups basically, okay, rest of them are hydrogen, let's say. So if these groups are opposed, like not same, but then also if they are in opposite side, so they are called as E alkene. Okay, whereas if you have these groups like this, if you have A and B on the same side of this alkene, they are called as like Z alkene. Okay, so that's what your E and Z alkene means. Now let's come back to these options and let's draw first of all these options. Okay, then it will be like it will be easy for us to solve them up. So first says that E1 chlorobutadiene. So how I can make that? I can make it in this way. See, just look upon this very carefully. Okay, so it is diene. Okay, because I have to do Diels-Alder reaction, so that diene has to be S-cis diene. Okay, S-cis means due to like through this sigma bond, it has to be cis in structure, and this is like chloro. Okay, so it's like, and it's 1 chloro 1,3 butadiene. So it's 1 2 3 4, so it's a butane, right? And 1 and 3 you have butadiene, so 1 3 butadiene, and on 1 I have chloro. Now how it is E and how it is Z, so that's what you have to check over here. So I'll just show you with the hydrogens attached. So this is hydrogen here, this is hydrogen here. So along this particular alkene, if you look, so the bulky group, or the one which is having more molecular mass, that group is like trans to each other. This is chlorine and the other group is this, right? So these are trans to each other, so all are on the opposite side, so that's why it is called as E alkene. So that's why its name is given to you as like E 1 chlorobutadiene. Okay, so 1 chlorobutadiene. So this is your E1 chlorobutadiene. Let's go for the next one. Now this is again E group, and this name of this is E1 methoxybutadiene 1,3 diene. Okay, so this all has to be in the same line. I'm just writing in the other lines because I just want some space over it, that's why. Okay, so I have just drawn three molecules which are given in the options. Now let's see which effects are working in which option. Okay, so you just have to look upon the effects over here. In option number 1, if you look, so there is a inductive effect caused by this chlorine group. Okay, so that effect is called as minus I effect. Okay, so I have a minus I effect. And if I go with option number 2, so over here this methyl group will cause a effect, and that effect is your plus I effect. Okay, so plus I effect. Also, since you have hydrogen attached on this CH3, so it will also called plus H effect, that means hyperconjugation effect. So it will have both effect, plus I effect plus H effect both. If you go with option like this third molecule, over here you have again this group will have a effect called as minus. Okay, so there are two effects working over it. First is plus M effect, mesomeric effect. Okay, and second effect is minus I effect. Now if you look that which effect will be dominant in each case, so you can say that plus M effect will be dominant over here. Plus M means the lone pair of these oxygen will be in conjugation with this bond, okay, and the electron density will be more on this like diene, okay. Similarly over here more dominant effect will be your inductive effect, and over here your like yeah, so similarly, right? So here you just have one effect. So now if you want to answer that which of these is most reactive towards this maleic anhydride, so for reaction in the reaction between the diene and a dienophile in the Diels-Alder reaction, you should know this thing that your diene should be electron rich, okay. So your diene has to be electron rich and your dienophile has to be electron deficient, okay. So over here we don't have to worry about dienophile because that's one only, that's the common dienophile for all of them, but you just have to see that where your diene is electron rich. So in the options, like in the molecules, you can see that in this molecule, in the third one, that is methoxybuta 1,3-diene, this most electron rich because of the plus M effect of this methoxy group. So that will be most electron rich. Then comes your methyl wala, okay. So this methyl molecule, this will also be electron rich due to the plus I effect of this CH3 group, and also your like this one will be least because this is not electron rich. Due to the minus I effect, it is becoming little electron deficient compared to the other two. So this will be least electron, like this will be the least reactive, okay. So what will be the order of reactivity? So this chlorobutadiene will be least reactive, then your pentadiene will be second one, and the most reactive will be methoxybutadiene. So your correct option comes out to be option number A. So that's how you have to answer this question. So to answer this question, you need to know two things. First is writing out like forming structure of E and Z alkene given by the name given to you, and second, that in Diels-Alder reaction your diene should be electron rich and dienophile should be electron deficient. You have to be very careful with the effects, and you have to check that whether which of these diene is electron rich, which of these is electron deficient, and based upon that you can answer this question. Alright, so let's take the next question. Alright, so we'll talk about this question over here, and it was asked for 4 marks in your CSIR June 2019 exam, and this was very smartly asked from your pericyclic reaction, or especially from your sigmatropic rearrangement, okay. So this was from sigmatropic rearrangement, and they have given a lot of reagents over here, and in between your sigmatropic reaction is happening, and like you have to be smart enough to understand that and to solve this question, okay. So it's a 4 marker question. Watch this video very carefully that what is happening in each and every step and how the final product is being designed, okay. So let's continue, and these are the 4 options. I'll just hide the options and just to show the mechanism and the everything of reaction, and we'll come back to see what option will be correct one, okay. So let's start with it. Alright, so this is the reaction given to you, and they have asked you about this only. And over here in the first step, I have just drawn the molecule again over here. And in the first step, it is being treated with LiHMDS. Now, for those who don't know about it, this is lithium bis trimethylsilylamide. Okay, so what is the name of this? I'll just write down somewhere over here. So this is lithium bis trimethylsilyl. Okay, this trimethylsilyl is in the bracket and amide. So this is the reagent over here. If you don't know about it, you should know about the structure and all of it, okay. So it's a organosilicon compound basically, and the main use of this is to take the acidic proton out of the organic molecule, okay, to form a carbon ion. So there are two positions from where it can abstract acidic proton. It can either like take a acidic proton from here, creating a carbon ion over here, or it can create a carbon ion over here. Now which of these carbon ion is stable? If you look upon this particular carbon ion, this particular one, so this is stabilized in two ways. One is it is in resonance with this carbonyl link, carbonyl bond, and secondly it is in resonance with this phenyl ring, right? Whereas this particular carbon ion is stabilized by the resonance with this alkene group, but due to the presence of this oxygen over here, and oxygen being like electron deficient group, it if it goes something like this, in that case oxygen will gain a positive charge, and it's not a correct way of making arrows, right? Because you are taking electrons away from the electronegative group. That is not correct. So that will not be a stable carbon ion at this particular place. So that means this carbon ion is not a stable one. This is the stable one. So that means your proton will be abstracted from this position. Now once the proton is being abstracted, we will get a carbon ion formed at that particular place, and the carbon ion will be in resonance with this oxygen over here. Okay, so let me just show you that what is happening. So this is the proton which is being abstracted. This bond will shift over here, this will shift over here, and Li plus so this will be O minus, right? One electron will reach over here, and lithium from here will be in the ionic form, that is Li plus, will form a like oxygen lithium ionic bond over here. So what will be the next molecule formed? Let me just quickly draw that. So we will be having something like this. All right, so we have pH, we will be having double bond and OLi. Okay, so this is what it will be formed in the after reaction with LiH, after reaction with lithium base trimethylcellulamide. Now in the next step, what you are doing is you are treating with it with TMSCl, that is tetramethylcellular chloride, or trimethylcellular chloride. It's not tetramethylcellular. So yeah, so trimethylcellular chloride, what it will do, it will just replace this lithium ion, and it will form TMS at that particular place. What is the use of doing this? It is just done in order to make it sure that this oxygen or this carbonyl will not come in reverse order, and it will not form a carbon ion at this place. Okay, that means the negative charge of this oxygen should not come back to to form the carbonyl bond over it, just to protect this group. Okay, or you can say that's just to make this part inactive in the reaction. TMS has been introduced. So if I introduce this TMSCl, trimethylcellular chloride, so the next thing which I will get will look something like this. So double bond over here, OTMS. Okay, in the place of lithium I'll be having TMS attached to this, and I will be having like pH. So double bond is already over here. So yeah, so I will be having pH, and this is the double bond over here. All right, so this is what I got till now after two steps, that is reaction with LiH-MDS and TMSCl. Now over here, the next reaction, that is heat, I'm going to give it heat. Now here your pericyclic reaction will happen, and this pericyclic reaction sorry, it's actually a sigmatropic reaction. So this sigmatropic reaction is of kind 3,3 sigmatropic rearrangement, and the name of this sigmatropic rearrangement is Claisen rearrangement. Okay, so Claisen rearrangement is happening, and how it will be done, I'll just number it up. If it is 1, if it is 2, and if it is 3, and this is 1, 2 and 3, so you can see easily that if this bond between 1 and 1 like oxygen and carbon will break, and this is like two allylic groups, right? So they can easily undergo 3,3 sigmatropic rearrangement or Claisen rearrangement in order to form the next product. So that will be done. This bond will shift over here like this. This particular bond will come over here, and this bond will move something like this. The next product which you will get will be something like this. Let me just draw this. One sigma bond will be formed over here, a double bond over here, a double bond O will be formed over here. I am having O TMS at this particular place. I have pH attached over here. Okay, so this is what I will get after doing that particular sigmatropic rearrangement. Now this was the pericyclic reaction which was introduced in this step. Okay, so this is what the major part of this reaction is. Now in the next step, you are treating it with pH phenyl selenium chloride. So if you treat with that, so what will happen? Over here I will be forming pH Se plus and Cl minus. So pH Se plus being that being electrophile, that will attack on the carbon carbon double bond, right? So what I will get in the next step is this. Okay, so this is SEPH plus coming from pH SeCl. So this will be like chloride ion will liberate from here, pH Se plus will be formed. So what will happen in the next step now? So the next step is very crucial. Over here, this lone pair of these electrons from this oxygen will come over here. This carbonyl bond or the electron density of this carbonyl bond will attack on this particular carbon, okay, at this particular carbon, and the next product will be formed. Let me just draw that, how that particular product will look. So how many membered ring will be formed? Let me just show you. So this is carbon number 1, 2, 3, 4, and since this carbonyl bond is taking part, so this fifth, so 5 membered oxygen containing ring will be formed. So this will be something like this. Okay, on this on the carbon number 1 I will be having CH2 Se, okay, because with this now this SEPH will be formed, right? So with this carbon I am having one CH2, this one, and with that CH2 I am having SEPH formed. Later on I'll be having pH attached, phenyl group attached at this particular position, and I will be having like double bond OTMS, okay, and this oxygen will be having a positive charge. Now I am also having, so this is what happened in this step. Now since I have a chloride ion from this pH SeCl, right? So that chloride ion and this TMS being a good, like good leaving group, so what this chloride ion will do, it will abstract this TMS and this electron density will move over here. So what will be formed, I'll just show you in the next slide. So this was what happened up till yet, okay. So this chloride ion attacked on this TM, like to take this TMS, and this electron density went back to this oxygen. And in the next step, in the presence of your H2O2, which was the last reagent used, your TMSCl, that is trimethylsilyl chloride, that what we have taken as a reagent, that will be eliminated back, and you will get a more stabilized product. So that will be 5 membered ring containing oxygen. pH is over here. Now you will be having carbonyl carbon over here, right? And over here you will be having SEPH. Now see, in this SEPH, if you just look upon, since you have taken, okay, so fine. So I'll just not introduce this H2O2 in this step. I'll do it later, okay, in the next step. So in the next step, I will do it. I'll just react it with H2O2. So what this H2O2 will do over here, now what I will get now, see, so just look upon this molecule very carefully, okay. So this will be like O. I am having 5 membered ring. I have pH over here, carbonyl group over here. I was having SEPH. Now because of this H2O2, this selenium group become like, it will become oxidized, and this will be SeO minus will come over here, and this will be like selenium plus, okay. Now we have hydrogen attached at this particular position, right? So we have hydrogen attached at this particular position, or rather I will show it in this side. So this oxygen will try to abstract this hydrogen, forming OH bond, and this bond, this OH bond, will shift in this direction, forming a double bond, and this selenium, because it is electron deficient, it will take this bond pair of electron, and it will take, like, it will be liberated out. So what will be formed in the next step, if you just heat this up, what is being taken out? So it is like pH SeOH, okay. So this was formed, pH SeOH was formed, and it's a stable molecule. It will it will be liberated out, and what is left out is your final product. So the final product will be your 5-membered ring containing oxygen, having a carbonyl bond, having a pH over here, and a double bond, exocyclic double bond. So this is your final product, and this is the answer of that particular question, okay. So now if I just bring up the options, just to make sure, just to show you that which option was correct, let's just look upon. So if you look upon the options over here, this was the question, and the correct option comes out to be your option number A, okay. So your option A becomes your correct choice, and that's how you have to answer this. So in this question, it was not only about your pericyclic reaction or the sigmatropic rearrangement, it was also about the reagents which are used. So whenever you are preparing for the pericyclic reaction, make sure that you also prepare for reagents also, because questions will be asked in a such a way that you have to use those reagents also to answer that question. So I hope this was quite a clear video, you understood it well, and if you have any doubt you can ask me out in the comment section below. And that's all from my side, guys. Thank you so much for watching, and if you are new to this channel, do subscribe to the channel, okay, and give it a like if you like this video, and you can ask anything in the comment section below. So thank you so much for watching. I'll see you guys in the next video. Till then, have a great day. Bye bye.